So my talk is about DNS research and analytics. First of all, what are root servers? I'm going to skip over this fairly quickly. There are 12 organizations that are responsible for hosting the root zone. ICANN is one of them. ICANN is responsible for maintenance of the root zone, but the hosting itself is done by 12 different organizations. There are 13 hosts, or to be technically correct, there are 13 host names, but there are over 1,000 instances around the world that have a copy of the root zone that serve the root zone to you today. This is done by Anycast. The INF function, this is an official function, it's one of the institutes of the internet, just like the IAB, just like the IETF. The INF function is responsible for root zone management, and INF function is operated by PTI, which is an affiliate of ICANN. All right, what kind of traffic, what kind of DNS traffic do we see at the root server? Well, in essence, the root server is one very big filter. There's an enormous amount of nonsense that's going to the root servers today. I'll give you an example of that in a minute. When the question to the root server is syntactically correct, the root servers are able to provide an answer. And of course, when we get a request for a name that ends with the label NL, we are able to delegate it, and we delegate it then to the servers that we delegate the resolver to the servers that SIDN are responsible for, and Morris is going to talk about that in a minute. So what do we see at root servers? In 2002, a colleague of mine, Dwayne Wessels, works for VeriSign now, did a study on traffic analysis to the root zone, to the root servers. And he came to the conclusion that about 2.15% is legitimate. Now, legitimate needs a little bit of explanation. For instance, you're able to ask a question about a private space address. Right? What is the reverse name? Or sorry, what is the name for an address that starts with that is 192.168, one of the RFC 1918 addresses? Now, in essence, that question is not kind of smart because it's a private use address space, which is different in all different contexts. You might use it in your own organization. You will have a different name for it. I'm not going to go into all these categories, but the important part to remember is 2.15%. That's not much. That's very, very little. I've done the same thing. I do this regularly. Not regularly. I do this continuously in a project called ITHI, which I'm going to talk about in a minute. We see about 13 billion questions. There's a number here that 98.5. 98.5% over 13 billion gets you to about 12.9 billion responses. I say giga responses, but that's a nerd way of saying billion. About 80% over UDP v4, about 14% UDP v6, 3.6% over TCP, let's say over 4% over TCP. I'm going to ignore TCP here. Not because it's not important, but my studies have shown that what is seen over TCP is actually a reflection of what we see over UDP. So there's nothing special in TCP that we don't see in UDP. And also, it's statistically insignificant. 4%, if you look at the 2.16% that I talked about before, 2.1% is legitimate, right? 4% over 2.1% is insignificant. One thing I forgot to tell you, it says the high frequency identical queries get one response. What do I mean with that? You'll be surprised of the stuff you see at the root. We see high frequent, we see a lot of queries for the same name, the same type, from the same address, sometimes even with the same identifier. The identifier in a DNS message is basically there to distinguish it between other packets. We see hundreds and thousands in the same second from a server. Why is that? We just found this out. If you have a firewall, everyone has a firewall, and you apply a rule to that firewall, the firewall is essentially blocking all traffic until all the rules have been added. That might take a minute or two. When that happens, everything is cached by a modern firewall. If you have a modern firewall, it will cache all this traffic up to a certain point. At the moment that last rule is in, right, allow, for instance, UDP over v4 going out, then all of this cache stuff in a millisecond is going out to the internet. Meanwhile, your DNS resolver inside is basically asking and asking and asking, not getting a response, and it gets a little bit aggressive. And so it builds up in your cache. Anyway, that's a buffer problem. Another reason we see 98.5 queries with a response and not 100% with a response is that we measure over UTC day. That's 24 hours, naturally. The queries that have been sent in the last second will get a response in the following second, which is the next UTC day. So not every query gets a response. We classify it as follows. This is a little bit more technical. In a DNS message, you have an AA bit, an authoritative answer. If I ask SIDN, what is your DNS key? SIDN will tell me what the DNS key is for .nl. And that's an authoritative answer. The NL servers are responsible for that question. The R code is basically a statement about the type of response that I'm giving. No error, the name exists. The type may or may not exist, but the name exists. NX domain means the name doesn't exist. And the no data basically means you ask for the name, but the type doesn't exist. So if you ask for an, if you haven't deployed IPv6 and you ask for an IPv6 address for www.example.net or .nl in this case, then the address doesn't exist. You get a no data response. So that's how we classify this. NX domain is pretty obvious. You're asking for a name that doesn't exist. And delegation is pretty obvious. The root doesn't have all the answers in the world. We delegate NL to NL, com to VeriSign, etc., etc. So about 2/3 is NX domain, and about 1/3 is delegation. So you know that resolvers cache. They cache information. That's what resolvers do. If it's a proper working resolver. So if you know the root zone a little bit, every individual record, if you will, in the root zone has a 2-day TTL, a time to live. So when a resolver hits upon a response and sees, oh, I can use this for 2 days, it will keep it in the local resolver for 2 days. Which is great. That means it doesn't have to go out the next time you get a question for the same record. So if you think about it, if you look at 1 day of traffic, then you should see, in theory, from one resolver about one question, one top-level domain, if you will, only one response, in theory. But if you actually look at practice, of those 34% delegation responses, 98% are duplicates. That's crazy. 98% are duplicates. And about 2% are unique. Going further, what does bogus look like? Bogus, I'm going to talk about it in a second as well. You see a lot of spam traffic, you see a lot of DGA traffic. I was planning to talk a whole lot about DGA, but I can give you a great example about DGA. What is a DGA? It's a domain generating algorithm. Now, it used to be associated with botnets, but right now, one of the biggest domain generating algorithms is something that you are currently using. It's in your browser. If you use Chrome, for instance, what Chrome does in order to detect if something on a network has changed, for instance, it wants to know if you're behind a captive portal. You know, when you're in a hotel or when you're at a conference, you might be behind a captive portal, so you have to register first. Chrome wants to detect if it's behind a captive portal or not. The way it does it, it generates a random string between 7 and 15 characters. That random string has no dots. So in DNS terms, it's a top-level domain. Your resolver has naturally not cached it. Your company's resolver, your conference resolver has not cached it. So it will go out and ask for it. And of all traffic, of all those 13 billion that you saw, about half of them is the Chrome random string traffic. That's ridiculous. That's very, very polluting. Before you say, can it be anything else? It's highly likely that it comes from the Chrome browser. We have not seen any evidence that it's something else. It's very hard to actually, if you look at root server traffic, The addresses are mostly from very public resolvers that everyone is using. We don't have access, of course, what's behind the resolver. Officially, we can't say it's Chrome, but we know how the Chrome browser works. All right. So in conclusion, 62% should never have been asked for in the first place, and about most of the 34% should have been properly cached. Now, the rest of the talk is about the broken stuff and the bad stuff. And within ICANN, we have two projects. One is called ITHI. That's the Identifier Technology Health Indicators. That will tell you a little bit about the broken stuff we see at the root. And the other one is DAAR, and I'll get to that in the last part of this presentation. DAAR is about the bad stuff that we see. ITHI, that's an initiative we have. It's health indicators. At ICANN, we are responsible not only for the root zone, the top-level domains. We have other registries as well. Not the registries that you would know, but registries like for the Q types that you can. The IETF, for instance, when within the IETF a new standard gets written, wants to allocate some code or some string for something that will get into some register. The IANA is responsible for that as well. So this is a long-term project that we measure all of these. The reason we say health has an analogy with human health. When we start thinking about this, we didn't know what good and what bad looked like. The only thing we could measure what things look like now. And if you look at how healthcare is done, and an example is the human body temperature, that should be on average 36.9. It might be half a degree off, depending on where you are in the world and medical history, etc., but on average 36.9. So when your temperature is 40 degrees, we all immediately understand that's off, that's unhealthy, something needs to be done. So using that analogy, we established over the last couple of years a baseline, what we think things should look like. And if something is off, it should pop up. Does that make any sense, that kind of analogy? All right. So we had 3 phases. We are now in the 3rd phase. We did some analysis first. What can we measure? What's out there? What we don't want to do is name and shame. We don't want to basically say this is bad or this is good. We are not doctors. We are just an organization that are able to measure things about the things that we're responsible for. We like to make that public. So there's no naming and shaming. We're not going to say this is good or this is bad. We're just going to provide the statistics. Phase 2 is done as well. We developed it. There's now a platform. If you on your browser go to ithi.research.icann.org, you can see a dashboard. We'll get to that in a minute. So we are now trying to sustain it. We add some statistics now and then. We only add statistics that we can continue to provide. So no ad hocs. The dashboard looks like this. This is a simplified dashboard. I have to read from the screen. Apologize for that. NX domain queries seen by the root servers now, as of November, is 75%. The reason that this statistic is a little bit higher than I had before was what I had before was a 1-day snapshot. This is what we see up for the whole of November until the 19th of November. That's when I created these slides. Number of resolvers that perform the DNSSEC validation, number of requests to top-level domains to the root, etc., etc. All of that is available in the dashboard. This is a little, excuse me, this is, what just happened? There you go. This is a better overview. You can click on anything you like here. Anything that's underlined, of course, is a link, and you get to more specific statistics. For instance, we have a top N of top-level domains that are being asked for that do not exist. Things like .local, .internal are in there, .corp, .home are in there. These domains have not been delegated, so these are basically locally configured domains that people use in private. The abuse stuff that I'm going to talk about after this. We can categorize things in phishing, malware, botnet, spam, etc. That's available in this dashboard as well. So we have certain categories, M1 to M8. For me, the most interesting part is the M3 because that's my part of the whole game. DNS route traffic analysis. We use samples of DNS route traffic, even though we see one of the 13 host names because we operate LRoute. The official name is now ICANN Managed Route Server, IMRS. We love acronyms. It's not an acronym; it's a abbreviation. Let me quickly go into DAAR because my time is almost up. If we look at, sorry, let's first this. Where do we get the data come from? Where do we get the data from? We get data from partners and we get data from internal. We get data from our compliance department. ICANN is a compliance department. What we try to move registrars to is to make sure they validate their WHOIS data. We make sure that registries that operate on top-level domains make sure, not the CC-TLDs, we have a different contract. We have no contract with CC-TLDs basically, but for the generic TLDs like .com, .net, .xyz, we have a contract with them and they need to be compliant. We measure that and we make those statistics publicly. But again, we're not going to say that this registry is bad or this registry is good or they do all the right things and they have DNSSEC. We don't do that. We just have an average statistic. Then we have white box, LRoute data. We have the route zone, of course. We do white box measurements with partners. What do we have? We have a little piece of code that runs on large resolvers on the public internet. It's very GDPR compliant. We are very allergic to PII. We don't want any PII in our organization. So what we have is basically something that sits on the resolver that analyzes the traffic that comes in, makes statistics, right, and just gives us the statistics. So we know what the top-level domains are. We don't know what the addresses are. We don't know who's asking for it. We don't know the full name. But this is a way to avoid PIR and to be GDPR compliant. Then we have black box measurements. These are measurements that are validated by us but done by other organizations like the Asia Pacific Network Information Center, APNIC. APNIC is an organization you might know. It's a similar organization as RIPE, or if you're in North America, AARON. What APNIC is doing with the Google AdWords platform, they basically have a little piece of JavaScript in a little ad that they buy from Google. It's placed on your browser, and then unknowingly you're part of a measurement. I talked about this. This is my privacy slide. I wanted to put it in here. This is the ITHI tool that runs on local resolver, gives us the statistics, no PII. All right, what is DAAR? DAAR is the bad stuff that we can measure. Now, we are not a security firm. We rely on security firms to give us data. And if you go to the to the anti-phishing working group, if you go to MARC working groups, these are working groups that deal with abuse, or anti-abuse, if you will. They have a lot of feeds that they can give us. They are freely, some of them are freely available, some of them are available under a contract. We get it from them. We then compare it to all the zone data we have. If you're a GTLD, you're contractually obliged to give ICANN your zone file. That doesn't mean we, as researchers, have access to it. You, as a registry, right, for a GTLD, you still have to give permission for us to analyze that. We have all that data, we analyze it. We have one of two CC-TLDs that we can compare it as well. These are CC-TLDs that voluntarily country code top-level domains, like SIDN. SIDN, we don't have their data, but for some top-level domains we have their data, and we can analyze that data using DAAR. Why do we do this? If you go to an APWG meeting, what we often see is a lack of understanding how the DNS world works. We know they have very good understanding of security threats. They, for instance, do DGAs. They disassemble malware. There's law enforcement in there that does their work. But there are hardly any DNS folks in there. DNS folks that you would see at organizations like DNS OARC or for instance the IETF. And we get often questions like, oh, hi, you work for ICANN. I have this problem with this domain. Can you delete it for me? And then I have naturally to say, that's actually not how it works, and you understand there's a missing part of education. It's the other side as well. The other side is the problem as well. A lot of DNS folks, basically, for them, DNS is their world. They understand there is abuse, but the reason you have DNS is not because people are abusing it. The reason you have DNS is because people want to go somewhere. And so for them, the abuse world, the anti-abuse world, is a different world completely. So for that, we have DAAR. We want to be able to educate registrars and registries, especially registries, about the abuse in their network. Again, we're not going to publicly name registries or top-level domains. We are going to give this information back to the individual top-level domains. The DAAR information, the way we assemble it, are just these abuse feeds. Right? We package it up nicely into a report. I'll give you an example of a report later. We use for that open source data, commercial abuse threat data, reputation blacklist data. Again, we don't do any analysis ourselves because we're not the expert. Moritz Müller, he's an expert in that. And he'll show you some stuff in a minute. SIDN has fantastic tools built over the last couple of years. I think Entrada is one of them. If I say that correctly, Entrada 2.0 is out this morning, I learned this morning. Fantastic product in order to analyze DNS traffic. Are there any large resolver operators in the room? Perfect. If you're a large resolver operator and would like to analyze your DNS traffic, Entrada is a fantastic tool. And I have no commercial relationship with SIDN, so when I say that, I mean this genuinely. All right. What's in the report? Daily counts of statistics. How much spam is there? How much abuse is there? How much DJs are there? Etc. Etc. DAAR collects data on phishing, malware, spam, and botnet command and control. Botnet command and control, that's the DGA stuff as well. But as we now know, DGA, domain generating algorithms, is much wider than just botnets now. All right. These are some of the organizations that allowed us to list their names on the screen, that give us their data. Some of them are commercial, some of them are open. These are well known to a lot of you. Abuse data, they have feeds you can just subscribe to. Is there an abuse list? No. You can't configure anything what we give you. We just give you a report. We don't give you some list that you can configure that stops traffic on your network. We are not that kind of organization. That's not in our remit, and we don't want to be there. It just shows how clean or how well-performing your zone is. All right. Some nice graphs. 79% spam domains. Now this is a little bit controversial to list on the slide like that, because spam. I mean, I can actually pretend. Thank you. I can actually pretend to be you. I can spoof your domain. It's trivial to do, especially with mail. So it's a bit controversial to have that. Why is that there? These are domains that are being used in actual spam, right? Where you can go get some phishing, where you can go get some malware. Excuse me. The other reason it's there is because within ICANN we have communities. One of these communities is the Government Advisory Committee. The Government Advisory Committee requests that we have spam in there as well. For me, the most damaging is actually the left three. Spam, there are solutions for that are that spam is as old as the internet is itself. The rest is actually still under development. People find new ways to fish. People find new ways to do botnet communication, etc., etc. And that's it for my presentation. So. Last slide. This is basically to show you, I said no naming and shaming, but this is the difference between new GTLDs, new generic top-level domains, like as an example of a new top-level domain, .xyz. Since 2012, a lot of new top-level domains came out. SIDN, for instance, has .politie, .police. And they have .amsterdam, if I'm not mistaken.
We don't have it, we do the backend.
Sorry, they're backend provider of, they're the backend provider of .amsterdam. I used to work in an organization that was responsible for the UK namespace. They have new GTLDs as well. The difference between the old and the new TLDs you see here. Now, even though these lines are very similar, keep in mind that the new GTLD zones are an order smaller on average than the order smaller than the old GTLD zones. So spam is much more prevalent in, abuse is much more prevalent, in my humble opinion, in the newer than the older. That's it. If you want more information on root server analysis, you can contact me.